exciting episode of Blue Glow Electronics projects and creations here, I would say. I'm doing something a little odd this time. I actually recorded about 10 minutes of video with this thing using a new camera, and in the process it did not record the audio, so I learned I wasn't doing it properly, but didn't realize that till way late in the game, so I'm going to try to do a little catch up. What I'm talking about is the transformers here on an RCA RS-177A console amplifier. It's got the original capacitors on it. You can see it's got 4 6BQ5 output tubes there. 2 input tubes, and I'll talk about those a little bit later. 6 CG7s is what they are. We find out a little later on in this video that those are not the ideal tubes for this amp, but for right now, it's the way the thing came from the factory. The thing came with 2 really good, nice quality output transformers from the factory, push-pull. As you can see in the back there, there is a single 5U4 rectifier, and you know, it's on a nice little chassis. Whoever I got this thing from had already painted the chassis silver, as you can see, kind of painted over some of the knobs. But the guy that's getting this thing wanted me to convert it. He's wanting to put a wooden crown all the way around. You can see I'm kind of giving you directions there. So he's basically not wanting anything on the outside edges of it, so that he can put a wooden frame all the way around this thing. The back side was already clean, as you can see there, but the front's got some switches and inputs or whatnot, and the other side was nice and clean. So told him I would do it upright and mount the stuff on top where I'm showing here with my fingers, instead of you know, having everything coming out the front or the back of the amp per se. So you'll see here the whole thing, pretty nice clean amp to begin with, really well made. Underneath of it, you know, strip ground wire from one end to the other. I love that. Thing is full of old wax paper, 0.27 400 microfarad, I mean 0.27 microfarad 400 volt capacitors here. I think it had about 7 of those in it, something like that. 1, 2, 3, 4, 5, maybe it was 5 of them. And all that'll need to be replaced, as well as rewire the whole thing on the inside. And you'll see more as we go along. This thing still has the power switch, which fed back up to the main part of the console amplifier. Those old capacitors, just known for being leaky at this point in time, so they definitely have to go. It's tough remembering what all I said the first time around in this video, but I must have been pointing out the ground bus there that it had in place from the factory. And like I said, just a neat little amp, nice little layout on it. Put a piece of wood all the way around that thing, and be a beautiful little amp for somebody. Kind of showing there on the left and back that I was going to mount everything along the sides, which you'll get to see here in a few minutes. Nice clean open spots underneath where you don't have to worry about a lot getting in the way per se. And as you can see here, it's just kind of the way this thing came wired from the factory. But we're going to dive into it and try to make this thing a nice looking little amp. What I wanted to show was the techniques that I use to convert an amp, more so than anything on this thing. So hopefully you'll learn a little something as it goes along. I know I certainly did. Every time I do one of these, this was the first RS-177 I had ever done, I believe. Okay, let's see if you can see what's going on here. So what I had was some binding posts laid out, and I buy these things online on eBay. Usually order them from, at least come out of Hong Kong, a bunch of them for about 12 of them for $5 or $6. At any rate, same thing with input jacks, and you learn when you're buying online which ones are the good ones and which one are not. It's a 30mm fuse holder that we'll end up mounting on top of this thing. And be careful when you're buying fuse holders, make sure you get the right length. And that's the power switch we'll add into it. Nice, neat little 3/4 inch power switches I picked up along the way somewhere. I really like those a lot. I've used them in several of these amps. And you know, just single post, single throw there, turns on and off the 110 volts. And I usually mount them on the front left corner there so you can easily turn this thing on or off. A little safety XY capacitor to go across the input of the power leads. And usually I use a CL80, which is a thermistor. Really good for, helps drop the voltage a little bit down from the modern 120. Drops it 1.5 volts or so. Also helps with the inrush current going to the tubes as well. I always put that in series with one of the legs of the input feeding into the thing. So just a few things I'm going to add to this unit. And man, they look like simple little parts laying there, like, wow, just bolt those right on and you're good to go. But as you can see, I use a handy dandy ruler to measure everything off and mark everything with as we go along. Just helps. I always lay it out and mark it before I start doing any heavy duty work on it per se. Well, we now have the amp laid out, as you can see, and we've got it marked off. Basically just used a ruler and a real fine Sharpie. Drew a line between those two holes. I'm just going to reuse those. Why have extra holes? If there's already holes in your amp, try to leverage those things. These are binding posts, like I said, speaker terminals with banana jacks in them, or you can screw them out and put a speaker wire through them and tighten them down. So it'll kind of go red and black, and then the next one will go red. And the next one will go black here, as you can see. Up next will be the RCA input jacks, and if you'll remember, R for red is the same as R for right. So the red one will always go on the right, and the white one will always go on the left. And then we got our power switch up front here, pretty easy to mount. And then you'll see there's two more holes here. The first one, we're going to drill a big enough hole to run the power cord through, as well as a strain relief grommet that'll snap around it. And we'll also, up in front of that, then put the actual fuse holder in place. I usually put my fuse holder near where my power line feeds in at. Really easy to jumper right off of and connect one end of the input coming in from the power line. As you can see, underneath the where those two holes were, where the RCA jacks will go, the speaker terminal is nice and clean. It's nice and clean where the RCA jacks are. It's nice and clean under there where the power switch is going to go. And just a few wires to watch out for as we drill in the power cord and the fuse holder, if that makes sense. Nothing too tedious or difficult to deal with there at all. Okay, we've got the drill press up on the bench now. And figure out what size drill bits we need, and we'll get busy drilling a few holes in this thing. Okay, the other thing we got out was our handy dandy shop vac. We will be using that all along the way. Just a small little portable unit to clean up scraps from the drilling up here while we're at it. And I went ahead and cut the power cord, and as you can see, I'm going ahead and cut some wires off of this thing. Get them out of the way because we're not going to need those as we get into the restoration. Alright, we're going to put the RCA jacks for the speaker terminals into these holes. But if you notice, I took this one apart, and there's always two pieces. One that kind of goes underneath, and one that goes here on the top, and these things will go down through. But you can see the little recessed edge here on the edge of this thing and on the edge of this. Right here. We're going to have to find a drill bit that basically fits that size, and you come over here and go through a box of drill bits, and what you're going to find is you're really not going to find one that large. So let me show you what we're going to do about that. Okay, what we're going to use is just a standard 3/8 inch drill bit here, and I'll show you from there what we'll do. And, the dog came to visit me this morning. Good morning, Jack. He's being kind of lazy. Okay, you can see here we've we drilled it out. I had my son help me. It takes kind of two people to hold that thing up here because this platform's not big enough to support this whole entire thing. So kind of hold it up here and you know, just get the drill going here like this. Grab the handle, go down through precisely into where you need. And we drilled the 4 holes, and you can see there's little metal shavings everywhere. So we'll grab the shop vac and get all that up. Okay, basically repeated the same process. Let's see, drill this hole, 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 and this hole. And you know, I'm not exactly concerned about them being perfect right now. I'll show you why. We're actually in my little bin of chassis punches here. What I have is a variety of chassis punches for punching holes in various chassis for meters and whatnot, as well as a whole pile of these. Most of them are made by Greenlee, but these are designed to basically go down to whatever depth you want and drill an even hole at that point. So some of them are a little more precise than others, some are a little bigger, but use these for panel boxes and lots of other places you want to drill a hole. But basically you start with this 3/8 inch pilot hole, which then lets you grab a hold of one of these things, and it'll actually, as the drill press turns it, it'll start cutting out, and you can see there's notches on it. It'll stop at each notch, and you have to kind of push it to go to the next notch, but you can get the size, exactly the size you need. So when I come back over here and look at this thing, then I can kind of come over here and eyeball this and figure exactly the size I need to get that size right here. So I'll show you how that's going to work. Okay, as you can see, I've now got it mounted into the drill press. As I turn this on, it spins just like a drill bit would. And we can lower that down into the chassis just to the appropriate depth to cut the right size hole. I'll do a couple of them and show you. Okay, I've got these 4 holes drilled out to the right size. If you'll notice, this little thing right here fits right down in there, and then it kind of seats and doesn't move left or right. Same here, doesn't move left or right. Doesn't move left or right. What I did was I went to a certain size hole, and then I started barely going to the next size hole. So you may be able to tell as I move this, I've got slightly beveled edges on these things. I've also got this handy little burr edge remover, and I'll use it and go around to remove any rough edges, basically, from these drilled holes. And really nice smooth edges at that point. Still got to figure out the size for some of these other things. We're going to jump on that right now. Alright, same deal. These 2 RCA jack plugs have got to go in over here and drop down in. However, if you'll notice, the little washers that come with them are beveled slightly here on the edges. So you can see there, I've got to find the right size hole for that so it'll drop down in there and fit snugly. Right now it doesn't. It's bigger than the hole. So we're going to ream these out slightly. Alright, as you can see, we got these 2 drilled out, and while I was at it, I went ahead and took the bit on down a ways. And that's the beauty of this thing. You don't even have to swap the bit out. You just start it and keep going down until you get to the size you want, and that'll be for the power switch here to fit right in tightly. Next, I got to figure out the fuse holder and what size that needs to be, as well as this little strain relief tab that'll hold the power cord in that I'm going to put right here. So we're going to figure that out real quick and drill this thing out. Okay, got all the holes drilled at this point. But you can see on the back sides here, you see how these little burrs exist on the various things. That's really what this little thing's good for, and I can't really do a good job of it with it in my left hand here, but I'll clean them up real quick and show you what I mean. Okay, we've got all the holes deburred at this point and ready for me to put the fittings and whatnot into. I got the drill press off the bench at this point, and got this thing flipped over, nice clean holes all the way around, and ready to take all its fittings and whatnot. Show you how that looks. Alright, a couple tools we really need to put in this these RCA jack, I'm not RCA, but banana jack speaker binding post. We need a 5/16 inch nut driver, and we need a good old digital multimeter. Show you why here in just a second. Alright, what we did was we put one in here. As you can see, the top part goes on this, this part goes on the other side. There's that little recessed edge right there, ends up going down inside the hole. This, the other little wafer part, the back part here, goes on this side. Then a lock washer goes, and a regular washer, and then you got the nut. And use that 5/16 inch nut driver to tighten that down good and tight. Next thing I'm doing is, if you notice, I got one end of my test lead probe set over here on this side of the chassis. And if you notice, I touch the chassis anywhere, I get continuity, so as I've got the meter set on continuity check. What I want to do is make sure that there's no continuity from this binding post to the chassis. That beep was me letting it slide off here, but because it's easy to get these off center slightly, and then all of a sudden your metal post is touching the chassis. But as you can see in this case, we're not grounding out. Okay, somewhere on this side, these RCA jacks, you can see they've got a little beveled edge here on one side of one of these, and then there's just a Teflon washer on the other side, a ground lug, and then the bolt. And it takes a 1/2 inch socket here to tighten those down effectively. And as you can see, I've already done one of them here. It's good and tight in place. I'm going to put the other one in. Similar story here with the fuse holder. This is just a standard 30mm fuse holder. It's got a little Teflon washer that'll go on the upper side. If you notice, when I come through the chassis here with this thing, it'll end up being right here. And then I've got to put this this washer and this nut on it and tighten them down. We're going to do that. Alright, look what we've got done. We've got a nicely mounted power switch that fits in there good and snug. Turns on and off up here on the front. We've got 2 jacks here for the input. We've got binding posts back here mounted good and tight for either speaker wires or banana plug connections for your speaker wires. We've got the fuse holder mounted in place now, as well as we've got a strain relief on the power cord here. So, you know, like I said, could have done all this on the back, which is typically where I do it at. But this guy was wanting to put a wooden frame all the way around this thing and have really nothing on the sides at all. So that's the reason we ended up mounting all this on the top. But I think it's turned out quite well. That was about an hour's worth of work. Did take 2 people to help hold this thing sometimes, but I don't think it turned out bad for an hour's worth of work. The other thing I just did was took these pieces off the front, and took this secondary connector that probably fed into the preamp or power switch within the unit or whatnot. Took it out as well, so that now it's smooth all the way around. Should be able to mount the wooden frame fairly easily. And we're back to this RCA, otherwise known as the RS-177A amplifier that I've been working on, and I've been reading a lot online about these things, and just an enormous amount of tips out here on audiokarma.org. Guy here, Tom Davis, seems to be a pretty good expert at these 6BQ5 amps, and he's got some recommendations here, and people have tried them and give their input and whatnot. So I thought I'd walk you through a little bit of that. Pretty small schematic here, but basically a couple things they're recommending doing. First off, on the very front end, there's really no coupling capacitors from the front end of this thing into these tubes, so they're recommending adding some basically some coupling bypass caps here on the front, so that if the previous stage, your preamp has any DC offset, it doesn't get passed to these tubes and actually change the bias voltages on them. So basically between the RCA jack input and right here, this 150 ohm resistor, that ultimately leads up and feeds the grid here for the first stage. Recommended put in 0.047 coupling cap, probably 400 volt. It's only a few volts at play there, so not a big deal. So I'll do that. Next thing being recommended is to change the size of these input resistors from 150K down to 10K on both sides of the input here, which we will do. Next up, talking about the feedback resistor. So coming out of the transformer here, feeding down, coming across, you actually have the feedback resistor right here. They're talking about increasing that value to 10K to decrease the amount of feedback coming back in, which ultimately feeds up to the cathode of this first stage of the amplifier. And then the other thing they talked about doing was reducing the cathode resistor here on the first stage. So that's this resistor right here. Actually reduce it down to 47, or this resistor right here. Reduce it to 4700 ohms, the same right here. It's kind of hard to read this schematic because it's not very clear. It's been photocopied, but we'll be reducing that down to 47K. Basically what that's going to do is give it a little more oomph on the front end, a little higher voltage coming into this thing, a little less feedback coming back from the output, and help drive the front end of this thing. There's also some recommendations playing around with this 6FQ7, replacing it with a 6DJ8 and a few other things. Basically the general notes are this is a great little amp from basically here forward, this part. It's 4 6PQ5s, 2 on each channel in a push-pull configuration, which always creates a great sounding little amp, but basically what's weak is the front end of it. And so without redesigning this whole entire front end, which is some of what we're doing here, basically I'm going to try to leverage as much as what's there as possible and then do some tube rolling or whatnot. The other thing, this thing has a ton of coupling capacitors in it in between sections, right here, all along the way. And they're 0.27 microfarad coupling capacitors, 450 volts. We're just going to replace those with like some 0.33 orange drops or something along those lines. That should be close enough. And then let's see, come over here to the outputs, trying to figure out which wires will actually feed the 8 ohm connectors I've got. And it's actually going to be the yellow and black coming off the output transformers here. There's multiple taps there, but we're just going to end up actually leveraging the yellow and black to feed the output here for the 8 ohm. And then the other piece I've been looking at down here is the power supply section a little bit. And let me show you what I'm trying to figure out right now. So kind of got it blown up here on my screen. Maybe you can see it a little better, but I'm just trying to kind of identify the transformer right now. So if you'll notice the input to this power transformer coming from the jack that would have fed from the previous stage, basically the red and the black, black, and black are the primary connections going into this 5SA4. The other thing people are recommending is replace this with a 5U4. Will help a lot with the sound of the amplifier. Basically a little more stable and a little higher voltage there. Let me take you over to the actual amp itself. Alright, so here's what I'm really chasing down. When I cut out this connector that was on this thing that fed to the other part of the amp, basically the preamp, I got all these little tags here that basically I cut loose when I did that, and a bunch of wires. So at the end of the day, I've got about 8 wires here. I'm saying, what are these? And the majority of them you can see go into the power transformer. So it was pretty easy to find the red black. You can see the stripes on it here, but this stuff's getting old and kind of faded. But that was the red black. So I connected one end of my multimeter to it, and then connected the other end of my multimeter. I just started poking around and found the darkest colored wire. It's really not black, but it's pretty close. And you know, once I connected it and this, then let's see here. I can get a good connection on that and a good connection on this. Hang on 1 second. Sorry about that. I was having a hard time getting a good connection with my camera in the hand. Anyway, I come over here and I'm sitting at, as you can see here, 2.0 ohms. So if I had the motor on continuity, you would hear it beeping right now. But what that's telling me is these two wires right here are tied together, and a little bit of resistance there from the winding and the coil inside the transformer. So these are my primaries, and these are what I'm going to be working with to actually come off the input wire here, to feed to the fuse holder here, to then run some wires over to the switch, which ultimately then get the two power leads here basically going into these two wires into the transformer. At least that'll give me my input. Then I got to come figure out the rest of these colors and what they mean to the output per se. Alright, what we done was came out of one side of the power cord here and basically soldered it into the to the socket here of the fuse holder. The other side here, I'll show you what we're going to do with it, and I'll show you what we're going to do with this wire. But one of the things you'll learn if you've ever watched any of my pictures on my website, huge fan of running cloth covered wire. I keep an assortment of just about every color known to man, but you know, this is the way it was done back in the 20s, 30s, 40s, 50s. You know, when this thing was built, this is cloth covered wire right here. And then along the way, the 60s, 70s, 80s came, and everything moved to plastic wire. And so what they make now is cloth covered wire, but it's got really good insulation here on the inside and good core, copper core. I find it kind of nostalgic, and I really enjoy kind of putting these things back the way they came. You know, it's kind of one of those vintage amp, 50 years old, but a lot of new stuff in it that didn't exist at that time frame. Just kind of takes away from it. So whenever I can, I kind of keep it all old school per se. All right, let me basically show you what I've done. In from the power lead, I've basically jumpered this wire onto this brown wire and used some heat shrink tubing in between here where I soldered it. Coming up to the power switch, I basically then leave the power switch and I come back down and I feed into this leg, basically the black, going into the power transformer. Okay. The other wire comes into the coming from the power lead from the wall, comes into this side of the fuse holder, comes out the other side of the fuse holder, and goes into the transformer. So basically what you've got is in from the wall, one side going through the power switch into the transformer, the other side going through the fuse into the transformer, into the main primaries of the transformer. Now we just have to figure, now that we've done that, we've just got 1, 2, 3, 4, 5 other wires to figure out where they go and what they are. But we can do that. Simple little, take your time, work through the schematic here, and we'll figure it out. And just a little more progress. You notice all these wires right here go to the heaters of the various tubes inside this amp. You know, all these 6-volt connections. And if you follow these up, it comes to these two sets of wires right here, which it kind of listed as yellow and yellow-brown. I found both those wires in here, and I found the brown wires that go over. If you'll notice, they follow up here, and they go to 2 pins here on the tubes. And then you follow the brown wires, they leave those tubes and go to these tubes and these tubes, on and on and on. They work themselves all the way back around here. So it's basically an AC voltage being applied to the heaters of all these tubes from one end to the other. And so what I did was I just connected the two ends, soldered them, put some heat shrink over them, and shrunk them up. And so that's the transformer to heater winding connections right there. So I think I showed you before, we had these two done. Just got a few more to figure out and we'll be done. Working on the RCA R24 console lamp today a little bit. And if you notice, I'm replacing all these old wax paper capacitors that are kind of an odd value, 0.27. Replacing them with some poly caps that are 0.33. It's the closest you're going to find. But I'm just one by one going through here, and I got a few more to replace at this point. But I'm going to do that, and we'll keep showing you what's going on at that point. I'm going to get this thing wired up and hopefully running in the next day or so. And we finally got them all soldered in here and replaced. Next, I'm going to wire up the terminal, the RCA terminals and whatnot, and the input here, and see what we get out of this thing. But before I wire these up, if you remember, we talked earlier, there's some changes I got to make to the schematics. I'm going to go ahead and do that, and then just going to insert some test leads in here. Make sure, basically, to the outputs and to the inputs. Feed signal in and kind of trace it through. Make sure everything's working well before I wire all this up potentially to the wrong place. Well, we've gotten a few more things done, traced some things down. So what I found was the outputs, they both go to ground. So if you'll notice here, I've got the black coming over here to ground and the black over here to ground. Both the inputs, the positives coming out of the transformer, it's these two yellow leads right here. And these two leads will end up going over to here and here on these terminal posts. And then there was a 47 ohm resistor that went from the yellow to ground. So I'm just basically going to tap across here. And these were old carbon 2-watt resistors. This is a new metal film 3-watt, believe it or not. Anyway, I'm going to end up tagging that across the inputs as well, just to get this back to where it was at specs. Well, just about got it all wired up. Got the yellow wires here going back to the transformer, the 47 ohm resistors across it. We've rerouted the input wires here all the way down and around. I've strip tied it off here because I don't want this input wire getting too close to these power wires. Brought it down here, as you can see, red to the right, the white to the left, and then I took the ground shield down and I created a bus bar here between the two grounds on this, and I brought it up and soldered it. This is just stripped insulation off of some house wiring. Is how I usually make ground bus wire. At any rate, tied it into ground here, and this thing has a natural bus ground going all the way across to here. So we just got a few more pieces to figure out here around changing out some resistor values, and we should be good to go. Hey, welcome back everybody. Early Saturday morning here, and trying to wrap up this RCA console amplifier. I found out something interesting here recently. If you remember, we were kind of working off of this schematic before, and I had some plan changes here on the front end or whatnot. And if you'll notice, it's a if you kind of get into it, what I found was that if you notice here, this says RS-177A amplifier chassis. Well, when I actually got in here and started looking at some of the resistor values and the way this thing was tied up back here with a little bit of, this is actually the feedback circuit right here, things weren't adding up. In other words, they weren't matching the schematic. So I went out and did a little more research, and come to find out there is a RS-177A chassis, which is basically the exact same amplifier, but they made some changes to the input here, as well as the feedback loop that comes off of the output transformer, feeds back right here, kind of does a little bit of divider network and feeds back across. So, at any rate, turns out what I've got here is this RS-177A, which was just a much earlier version of this. However,
There's some slight differences in the output transformers is what I actually found between these two models. So I couldn't just convert this amp over to look like this. They actually changed the output transformers between these models. So anyway, started following this schematic, and right now the way I've got it set up, I've got the amp finished, and you can see here I've got the outputs coming out of the output transformers. There's a if you'll notice here, there's a 47 ohm resistor to ground on each of the outputs, and I've basically done that here at the output post with a 47 ohm 2-watt resistor, which, as you can see, then feeds over here to the ground bus bar. So we've got it all put together nice and neat. Got all those old kind of wax-filled capacitors replaced with new poly caps. And it's stock right now, is what I would tell you. Got the inputs fed in here. Was able to use the original input wires that originally fed all the way across to this little jack. And instead, what I've done is I just rerouted them over here to the other side. And you notice I grounded the ground down to a bar here that I tied between the two ground tabs on the RCA input, and then I brought this bar up and tied it into the ground bus, and then the right and the left respectively. So let's do a little bit of testing here. What I've done, let me spin it around a little bit and show you. I'm coming out of the output jacks back here, and I basically just feed up into my audio dummy load here. This is just it's an old HP access switch for BNC connections for like a video camera switch, and I basically gutted the box, and I tied all these outputs together with the exception of this 1/10 output, and then I put inside of it two okay, a little easier to show you with some that are not in. So what I mounted inside of that box is two of these Dale 250 watt, if you can see here, 250 watt 8 ohm 1% resistors, and this NH up front here stands for non-inductive load. So kind of NH for Henry or inductance. But those things are, you can see they're pretty good size here, about I guess 4 inches or so long. Pretty heavy duty resistors, and you actually, I mounted two of these just like this, kind of staggered like that, inside this chassis here, and then basically tied the inputs from these wires to each side of these, and then I also tapped the outputs to all these so I can feed it to, you know, oscilloscopes, or you know, spectrum analyzer, or an audio analyzer, lots of different pieces that I feed out of this thing with. At any rate, so basically when I flip the switch down here on dummy load, then I'm playing into these resistors, and if I flip it to speaker, I'm playing up here into some bookshelf speakers up on the shelf. So feeding out of the thing from that, feeding into it from a B&K 4003A, basically just a function generator that has a built-in frequency counter. So that's a 1 kilohertz tone. If you'll notice here, I'm on sine wave, and I'm feeding out of this into a BNC connector that then converts BNC to mono RCA, and I feed a cable down here, which then goes into the, as you can see, the left and right RCA input jacks. Got that amp turned on right now. My variac is off, and I've got it spun way down. I'm going to flip it on here, and if you'll notice over here, I'm sitting pretty low right now at 40.5 volts. So I'm going to cut the lights out here, and so I don't have any loud noises, popping, humming, or anything at this point. Let's see if I can crank this thing up. I just took it to 50 volts right there. And at some point, and you can barely see it right here, I'll try to point it out to you, but right here you can start to see the heater glowing on these tubes, the filaments. So the amp's actually starting to warm up a little bit at this point, and but still don't have any output coming. I can't hear anything at this point in time. I'm sitting at 51.3 volts. I'm going to turn the variac a little more till I get to 60 volts. I always like to bring up these old amps really slowly like this. A couple reasons. One, if I had any failures, I'd hear, I'd find it at low power versus at high. Two, it does a good job of helping reform these capacitors right here. And I don't know if you can hear it or not, but faintly in the background, I have some audio signal actually coming out of both speakers now. I can hear the 1 kilohertz tone. I'm going to crank it up to 70 volts. This is about the speed I bring stuff up. I usually crank it 10 volts at a time and wait about a minute between each 10 volt increment. There's really no hard and fast rule out there. I've searched and tried to find it myself on how to bring this stuff up, but yeah, it just tells you to use a variac and bring it up slowly, and that's kind of what I've been doing for 30 years or more. As I turn it up each time, I can hear a little bit louder the audio. I'm going to go up to 80 volts now. Okay. And what I'm going to do is I'm going to turn on my oscilloscope. I've got two oscilloscopes here. One's a Rigol DS1054Z, which is a digital oscilloscope, and I mostly use it with a probe for any kind of digital work I do, or just probing around inside of something. And then I've got this Tektronix 2246, which is probably one of my favorite scopes of all times. They're not very expensive. You can get one of these fully calibrated, ready to go for around 300 bucks or so. So this red input here is on channel 1, which if you'll notice goes up here to the output of this. And I'm going to change it over here to channel 1 and take it off of channel 2. And then we can start looking at what we're getting on the output here. So you can see we've got a sine wave here at this point. Probably not the cleanest sine wave I've ever seen, but I'm also running this thing at 80 volts. And it's designed to be ran at 120 volts or so. So I'm going to crank it up just a little more here. Okay, we're up to 90 volts at this point. Still a really nice sine wave. A little bit of distortion here on the downfall. And, that may be something, if it doesn't go away, I'll have to play around a little bit on the bias of this thing to see if I can get that right. These things kind of have a fixed bias if you look here. Turn the light back on. And I'm going to flip this thing to dummy load. So you notice the sound goes away. Right here, this set of biasing resistors here on the cathode of these two input tubes. Basically, this resistor here is one that you're going to want to play around with the value. You see noted here, change as needed to get 65 volts at cathode. Could put in a variable resistor here, and so you can turn it and basically bias each of these input tubes, but I'll play with that in a little bit if needed be. Let's see what we're getting. We're still getting a nice clean signal up here on the output. I'm playing around with the triggering just a little bit. That's the reason I'm losing signal. There we go. Let's crank it up to 100 volts. Okay, That's at 100 volts right there. We'll do some math here in a minute and see if we can figure out how much power we're capable of driving out of this thing. Let's see. Yeah, I just turned on another piece of test equipment. We'll check it out here in a second. Okay, let me show you where I'm at on this thing. Basically, I'm not done. However, in a good place. Let me show you what. So I got it up to what here, 118.7 volts. So the unit's performing well at full voltage. No sparks, no hisses. Capacitors seem to be doing fine. If you'll notice here on the sine wave output, nice clean sine wave at that point. Couldn't really ask for anything much cleaner than that. And if you come up here onto the spectrum analyzer, if you'll notice here, as we come across, there's a marker at, and that's, you'll notice it when I turn this little knob here, it's the little red, the little glowing dot. It's about right here right now. As I move that across, that's the marker. So when I get it on the top of that little peak right there, it tells me I'm at 1 kilohertz, which matches up with the 1 kilohertz over here. The beauty of it, that's my signal. If you'll notice to the right of this, there really is no other little blips. I'll give you an example. If I change this thing over to a square wave over here, all of a sudden you'll notice blips here, here, here. And if I scroll over till I get on that second blip, if you'll notice, I'm at 3 kilohertz. Basically, that's a harmonic, an even order harmonic. So 1 kilohertz, 3 kilohertz, that'd be 5, 7. But if you'll notice in between here, there's one at 4 kilohertz. That's kind of an odd order based off the 1 kilohertz. So at any rate, with this thing at a sine wave, beautiful signal here. Really no harmonics, no spurious emissions, nice clean amplifier. Beautiful sine wave output. So that's the good news. I'm going to cut this off to kill the volume a little bit here. It's a very loud piece of equipment. So 3582A spectrum analyzer from HP. Amazing little units, by the way. But back down here on the amp. Here's the problem, and I wish it was an easy fix, but it's not. These amps, and I've read a lot about them, these old RCA amps, specifically this RS-177 chassis, has a very low, these first two tubes in it over here on this side, the input tubes, which are these 6CG7 tubes, they are extremely kind of weak on the front end. In other words, they don't drive the output very hard. So what it's relying on is kind of being driven very hard on the input here coming from the preamp of this unit, that kind of drives through to the output tubes here. But when you drive it with typical line level, which I was doing, the voltages I was putting into it up here coming out of my function generator, similar to what would come out of an MP3 player or any line level device, CD player or whatnot. It's not enough to drive this thing to put out a lot of output. I measured the output here, even at full peak power here. Let me show you. So peak to peak voltage here about 1.29 volts with this thing being driven as hard as I can drive it up here. You do the math, 1.29 times 1.29 divided by 8, you got about 0.2 of a watt coming out of this thing. So it's while you can hear it, I'll flip it down here, flip my switch to speaker. Sounds good, but just not a ton there as far as sound goes. So we got a couple choices, and I was afraid I'd get into this. I just thought I'd put it together the way it came from the factory, get it all cleaned up, and then see what see how much it needed on the front end. But basically that's where you get into making these changes outlined here on this schematic. Kind of got to lower the input resistance here to let more drive get in. You've got to change the bias here to give a little more oomph to these second stage of these tubes. And you got to make some changes to the feedback resistors here, driving this thing back as well as there is a recommendation to replace the 6 GC7 tubes with 6 DT8 tubes. So I'm going to talk to the customer that owns this thing and see if he wants me to go through this set of steps here, which would help drive this thing a little harder. Alright, let me turn the volume down here on this. I think we finally got this thing wrapped up. About as good as it's going to get without a total redesign of the input circuit. What we did was these two orange drops here, I removed some 390K input resistors and replaced them with these coupling capacitors. That brought up a little gain on the input. And then what I did over here was added some additional resistors here, some 3K resistors in series with the feedback loop in this amplifier, which helped raise the gain as well. And we got it flipped over. Amp looks good, you know, nice neat power switch here. The driver tubes, the output tubes glowing nicely. All the connections on it look nice. Hey Lucy, what other Australian Shepherd do we have? She's a pretty dog. Anyway, that's about it for this thing. You know, it's one of those, it sounds good. The frequency response across the entire amp sounds great. Just wish it had a little more oomph to it is what I do. It just, without totally redesigning this amp on the front end here and replacing these tubes or adding some additional tubes to it, it sounds about like it's on half volume of what most 6BQ5 amps would sound. So it's one of those, I had to figure out whether we want to go any further in this or not. If we do, it's a major undertaking per se, if that makes sense. But if you just wanted a nice little amp for an office size room or maybe a bedroom and wanted to listen to it.
Today, it smells like an airport runway, jet fuel stenches in the cabin and lights flickering.
It's a good sound on the lamp. Hope you learned something here. I certainly did. And we'll keep them coming. Thanks again for watching our videos at Blue Glow Electronics.